Today on Hot Medical Topics, I'm going to share with you a paper where the doctors are talking to the scientists and they have discovered that the fat cells are possibly talking to the brain. And based on that, they feel as if this may help to control and regulate weight loss, weight gain. When you come into my computer with me, you're going to see there's a combination of modern medicine, functional medicine, physiology and biophysics, sports medicine, nutrition, and science. It's pretty awesome. Come, I'll show you. Your brain actually talks to your fat cells, and that could be the secret to losing weight. Researchers have uncovered newly identified sensory neurons, ferry messages from fat tissue to the brain, according to Science Daily. Now, this paper was published in Nature. Basically, the discovery of these neurons suggested for the first time, that's the part that got me, for the first time that your brain is actively surveying your fat rather than just passively receiving messages about it. That's according to Dr. Yi, PhD. So the implications are profound, they said. Can be streamlined to the brain, finding that it can directly send messages to the fat tissue and influence the body's metabolic processes rather than responding to hormonal signals in the blood. When I was in residency, I was also in the research program, and almost all the doctors were either MD, PhD. We all spent time in the lab. And at that time, it gave us a chance to have scientists and doctors to be thinking and looking at things from a mechanism of action and a molecular level. And now it's like the doctors just 12 hours, is my shift over? I don't feel comfortable. And so there's a disconnect, and if there are any medical students that are listening, any residents, spend a little time in the lab, be a research assistant. And when you get your board certification as a doctor, you will look at the patients so different. You'll have a totally different experience. So to see how the neurons in the adipose tissue worked, researchers used a second new technique, which is named ROOT, retrograde vector optimized for organ tracing. This allowed them to selectively destroy small parts of the sensory neurons in the adipose tissue to observe what happened. Through this, researchers discovered that nearly half of these neurons didn't connect to the sympathetic nervous system. Yeah, we're going to go there. The network of nerves that helps your body mobilize its fight or flight response. But instead, Science Daily reported to the dorsal root ganglion, an area of the brain where all sensory neurons originate, which are responsible for firing and sending off signals to the rest of the nervous system about the information that they have received. When the sensory neuron communication was silenced, the sympathetic nervous system began converting the white fat cells into the brown. Now, what is so huge about that? That's a big deal, right? Because white fat cells don't burn. They just stay there. That's like the built up adipose tissue. But the fat tissue that can degrade is the brown fat tissue, which can burn calories through a process called thermogenesis and speeds up the body's fat burning processes. And when they reinitiated the nervous activity, they saw that it converted the white fat tissue to the brown. All right, so let's look at another paper. This paper is discussing the white and brown adipose tissue and how they are essential for the maintenance of proper energy balance and metabolic health. Now, even if we don't exercise, if we don't do anything, just breathing, just thinking, just existing, we still burn calories. We still need energy. What are calories? Calories are energy. So what I appreciate is that they are getting down to the root. They're getting down to what is really going on, the mechanism of action, right? Looking at the white and brown tissue, they're essential for the maintenance of proper energy balance and metabolic health. In order to function efficiently, these tissues require both endocrine and neural communication with the brain. This paper is from 2019, right? And the paper earlier, that I just shared with you that was discussed today said that's the first time. That's the first time. We got to respect the people who came before us. So it's not that like all these findings are first, they just were not being discussed. The minds were just not coming together. And I don't know if it was like the pandemic or I don't know what it is, but now minds that previously were on different sides of the sidewalk are now on the same side. So let's say this paper is from a biology magazine from 2019. The brown adipose tissue, as well as the inducible brown adipocytes that appear in the white adipose tissue after stimulation, are thermogenic and energy expending. But keep that in mind. This uncoupling protein 1 mediated process requires input from the sympathetic nervous system releasing norepinephrine. I just put this in here just to give a kind of a overall refresher course. Physiology classes in session. We're back in school. No frog legs, just plain old physiology. So if we go down to the nervous system is split into the central nervous system and the peripheral nervous system. The peripheral nervous system is split into the autonomic nervous system and the somatic nervous system. And the autonomic nervous system is split into the parasympathetic and the sympathetic. So basically the parasympathetic is the involuntary part, where we can't make our heart beat. We can't say beat heart, or we can't make our bowels go through peristalsis, but that's what takes place. That's leading to this discovery. And then the sympathetic, fight or flight, right? But outside of just this overall diagram, remember this picture, everyone, where we have ganglion. We remember we had the efferent and afferent nerves, the nerves to go away from the body, the nerves to go to the body, the sensory and the motor nerves. So all of this is actively going on. And I put this on my notes from NASM because in NASM, this is basically what they teach. They teach that in order for you to have healthy exercise, your nervous system, your muscular system, and your skeletal system all must work together. So that's one of the reasons why it's so important to be able to just get up and go, and mobility and flexibility as we age. Because if you lose one out of the three, you're going to have a problem, which has been proven to cause a decreased longevity of life. But staying on track with regards to weight, the bioenergetics and the metabolism is what we're mainly talking about. Exercise metabolism. Now, going to physics, what is exercise? What are calories? It's the energy, right? And the energy is the thermodynamics. The body is an intact closed system. Like all other systems in nature, the body must follow the law of thermodynamics, which is that energy can neither be created nor destroyed, only recycled or converted from one form into another. So it's not like the energy goes away. It's just converted from one form into another. In humans, this is referred to as the concept of energy balance, homeostasis, which briefly the energy entering the body in the form of macronutrients. And what are the macronutrients made of? Come on. I know you got it right on the tip of your tongue. The carbohydrates, the proteins, and the what? The fat. Right? So, and they're coming out of the body, and it's always accounted for by a change in mass, weight. If someone consistently expends more energy than they consume, that person will lose weight. Duh. If someone consistently consumes more energy than they expend, that person will gain weight. Therefore, all the energy someone consumes is either used to perform body functions or stored. And when the energy is stored, or when the fat is stored, what kind of fat is stored? The white fat, which is one of the main reasons why we have signs of increased weight. Dietary food provides energy to sustain life and support physical activity, but not directly. it first must be broken down into the digestive system into smaller products known as substrates. Proteins. So basically, the conversation has always been going on between the brain and the fat. There are many things that have taken place in our diet, our lifestyle, our circadian rhythm being off, increased cortisol surge, increased norepinephrine. Everyone's so stressed out and anxiety that our neurotransmitters are just so whack. If someone has a problem losing weight, that normal mechanism that we've known about in the brain and the correlation between the brain and the fat cells, it can't function like it normally would because almost everyone is walking around with hormonal imbalance. So I would say that that paper would definitely be on track if our diets were in par with the concept and if everyone had their hormone levels checked. Meditation, sleep, relaxation, going back to functional medicine's whole concept, root cause analysis. Figure out the problem, address the pathology from the point of the problem, and the problem will resolve. But I'm excited, guys, because a change in medicine is being considered. And instead of just, hey, if they have this symptom, give them this. If they have this symptom, give them that. It just looks like they're more so going into the process of thought. Like, hey, she has that symptom, but she also has this, and she also has that. And I really think that we are on the road to attacking obesity if the scientists and the doctors keep having open conversation.